Okay. No. Welcome everybody, welcome to Meadow, and thank you to all the friends who we often have coming to our Meadow events, and also for those who are here for the first time. Welcome to the end and the conclusion of our first SPACEtrek bootcamp run on the African continent. This is all part of a program which is involving building the first privately owned satellite from Africa, which is going to be launched later this year in 2016. This is a program that is currently being sponsored by SPACEtrek South Africa, and we have the Chief Operating Officer, Mr. Craig Aaron, who's going to take us through a short presentation, and also really to share with us why SPACEtrek South Africa found this program to be valuable for them as a sponsor. Our other partners are Morehead State University. You're going to be hearing from Dr. Ben. Cape Town, Xanthia Limburg is joining us. They're very strong partners of ours. And Air Products and Chemicals, they've been very involved with us in terms of the helium and the launching of the balloons, which you're going to see a little bit later. Sorry, Carla, I think the feedback's gone, so isn't that marvelous? So yes, so let's go to this whole thing about the first privately owned satellite. What we did is we've bought a satellite from Interorbital Systems, and what we've done is we've bought a CubeSat from them, as well as a conversion kit for a CubeSat, which came available 3 months after we had originally bought our CubeSat. And it was only after we bought it when we found out that we, in fact, the only private organization from Africa to have ever been listed, been launched, entities or from countries themselves, but nobody from the private sector has launched as yet. So there you can see we are on a manifest, so that is proof that yes, we actually have bought it and we're not just making it up. So what is this satellite going to do? So it has a polar orbit. Suddenly I forgot all about that, and I thought I've got Dr. Ben Malfa sitting in front of me, and here I am forgetting what a polar orbit is. So what it does, as you can see by the graphic, what's going to happen is the orbit is going to go over the poles of the Earth, and then you can see the graphic with the green lines. So that shows actually by everybody on the planet. The height of the orbit is going to be around 310 kilometers, and what we can expect is that the satellite is going to be visible twice a day. You can see in the third graphic that there's a laboratory assistant who's holding a typical CubeSat, and so it has exactly an empty liter of milk with a couple of electronics, an aerial, and something to power it. So what we've got is we've got various stages of our program, and the first stage we began just over a year ago, and that was to run space prep boot camps. These space prep boot camps is where we go to schools within the broader city of Cape Town, and we are running one-day workshops at those schools, and I'm going to take you a little bit through that in a short while. And at these workshops, the young women get to build jiggy bots. This is electronics that they put together, and it's able to move around by itself. And currently, up till now, we have impacted exactly 110 high school learners. And how do we do this? You can see above the screen is a very beautiful picture of 2 trucks. The newer one, which is in the front, is actually the classroom that we use. So here is our picture once again. And it's the classroom that we use to be able to go to communities and to be able to deliver those programs. And our core sponsor, who assists us in going to those schools, is Craig Aaron. And Craig, I'd like to hand over to you, please.
Thanks very much, Judy. Clearly, I don't have to stand that close like I normally do to a mic today. For those who are, I do believe there are people watching and not present here today. Maybe we should have changed this whole place around and had the background to probably the finest day in 2016 so far in Cape Town. Why Isuzu Trucks involved in a project like this, I suppose, is clearly a logical question. Well, if you know from driving past them on the road, these pieces of equipment have lots of technology in them. They require many types of intellectual inputs from engineers that need maths, science, technology, design, etc., etc. And the only reason I can stand here and run a successful brand and company is because we have those type of people in our midst. So a lot of the let's call it the people in the general marketplace don't see under the skin what happens. Whatever you see, sit on or observe today or eat, that product got brought to you to where you are somehow, generally by truck or some form of transportation. So I must remember to press the button. That you already know is me. But core to the Isuzu trucks, when we talk about trucks, I mean a pickup is a truck, but Isuzu have in the world. We are a Japanese-based company that are in 150 plus countries in the world, and in most places we are market leaders in our, and Isuzu is very well represented, I know, in the US. So from this perspective, for us, I'm recruiting for the next generation who should be standing here in my job, and certain other people in my company. So from that perspective, on the second line here, every truck that goes into the marketplace is actually an economy. It employs a driver, it employs a technical person to look after it. It requires pickers, packers, crew, etc. And that truck employs people as you go along. So the more trucks you put on the road, the more people you employ. Step back. How do you design the truck? Those people, those future engineers, designers, technical people. And if I could show a view of what my office looks like today, 45% of the people that work in there are ladies. But I'm surrounded by technical people, which the ladies don't quite represent enough of that side of the business because they're in finance, distribution, the economic. Call it in the more technical side of the business as well. So harnessing technology and the development of the products we offer to the marketplace that makes us successful is where design comes in, and what needs to be making something that the consumer wants, or something the consumer can buy because it's got to make him Isuzu Trucks in South Africa became more of an enterprise. We don't just build a piece of hardware in a factory and ship it out the front gate. We started acquiring businesses further down the logistics train, the bodybuilders, things that fit cranes, any more to the vehicle of a truck that can create more of a usage of that vehicle. And that comes with people who can design and provide those services. So hopefully all this gives you an idea why a brand like ourselves is interested in STEM. Part of what I've discussed on the slide there is these downstream environments where we have to design bodies to go onto the trucks, the functionality, the efficiency of those, and being able to provide solutions to customers. We're in a country which is defined as a developing country, not developed. Sometimes there's a bit of a fine line. If you look out to the waterfront, you wouldn't say it's developing, it's pretty developed. But our economy is a developing economy, and we need to be growing generically in this environment. And that's where, as a supplier of technology, services, logistics, we South Africa is an extremely long way away from anywhere, if you look at the continents and if you look at geographics. So essentially we've got to do an awful lot here, because to import things costs a lot of money, because they've got to come on a boat or an aeroplane, and it takes a long time. So we need to resource locally in manufacturing to be able to do a lot for ourselves here. And we need the intellectual properties and the skills to do that. A lot of these things we're mentioning, you read in the newspapers all the time, not just in South Africa, but around the world. Our needs in developing economies are no different to others. So we have a country with a 25% plus unemployment ratio, which is that, but at the same time we need to make a lot of those who are employed far more employable, because if, again, sorry if I'm being negative, the facts of what we read in our economy currently are failed organizations, failed parastatals, failed governmental organization, because there is no skill at the level or intellect to run those businesses successfully. And we need to, at this stage, improve that future intellect level to make our whole environment successful, because at the end of the day, that will create positive impact on employment in future generations. So this is not a short-term thing, it's a long-term thing. You've got to start somewhere, and you've got to work methodically and hard and committedly towards getting. Judy said a lot, and there will be a lot said today. I'm not going to harp on it too much, but it is quite logical when you go through some of the numbers on the slide, the level we're at. The fact that in future generations, well, let's not put future, in the near future, the trend is the wrong way. The skills are following the downward trend instead of the upward trend, and we need to find a way with the programs like this to start forcing the trend to move in the opposite direction, and recruit, skill, get people to familiarize themselves where we can put a spin on, a positive spin on the future impacts we can make. The matric results, which are probably still very hot off the press, last week, Thursday, Friday-ish, again, don't suggest the trend is going in the right direction, and initiatives like this needs to help, because you can't just complain and point fingers and talk about it. You've got to do something about it. So unfortunately on the maths particularly, the trend is going the wrong way for 2015 versus 2014 and 13, and we need to try, and people in the industry and across the economy aware of what we can do with certain of these type of events to change that parameter. So some of the stats, just to reiterate the base we're at, 25,000 schools, 1 in 4 doesn't even offer maths, which is not a great stat. To get into the economy to actually make a difference. So without trying to baffle you with too much of the jargon, and if you throw it right the way through, less than 10% of that crop of local learners for this year are actually going to make it into the economy that actually can make a difference at an intellectual level. Opportunity to change. So from our perspective, again, with Isuzu, we've proved there is an ability and a capability to do something with the people who are going to present today. Looking forward to that. And ready to go ahead so that we can get other people other than ourselves on this drive, if I can answer some more, so we can put more initiatives into the marketplace in many provinces, at many schools, and drive the intake of STEM into the universities in the future. I use the opportunity of the picture of Sipho Sandler, who I appointed into one of our subsidiaries in August last year. He's a similar age to me. Industrial engineer, and does a fantastic job, and he's a great mentor, and we need more of them, particularly in the ladies' environment as well. So there's a good reference for you for the future. So from an Isuzu perspective, we're very proud and very pleased to be involved with Judy, just to try and get the initiatives going at new levels, and thank you for our ability to participate with yourselves. Look forward to what you have to say. And I will say in closing, I don't know all this technology of jiggy pods and things and the satellites. I don't profess to want to know, but I'm after the outcomes. I'm after what this produces in people at skills levels that can make a difference in all the businesses. The economy, etc., needs successful businesses, and those businesses can only be run by successful people. And we need to produce successful and bright people, and that's what we're after. So thanks very much for allowing us to be here, and look forward to talking to you all during the day. Thank you.
Craig, thank you very much. What I'd like to do is that I'd like to introduce our next speaker, who is Xanthia Limburg from the city of Cape Town. And Xanthia, I believe you're going to come up and share with us a whole lot of your role and responsibilities and where we're going as a city, the great city that we can see so well from our venue. Thank you.
I'm extremely honored to be providing an address at such an event where there are so many notable attendees and passionate women. A special thanks and welcome must specifically go to the SPACEtrek USA Director Jennifer Carter, as well as the CEO of MEDO, Judy Sandrock, and most importantly, the 14 remarkable young women amongst us who have just arrived from the SPACEtrek 1-week boot camp. Not only is the caliber of young women here today extraordinary, but the work that you have all been involved in continues to amaze me. As a public representative for the city of Cape Town, in which this STEM training and development is taking place within, I thank each and every one of you for positively contributing to not only ensuring that South Africa is building a sustainable pipeline of mathematicians and engineers and scientists, but that women specifically are being encouraged to participate in these fields as we together continue to drive the gender narrative. In each one of our lives, I have no doubt that we have all experienced being put into a box on the basis of one's gender. I have also no doubt that whether it be in our work, home, or religious communities, all of you here today have experienced what it feels like to be considered a lesser human or lower down on the priority list on the basis of your gender. I know from my first-hand experience during both my educational years and during the course of my political career that this marginalization rings especially true in the professional fields of science, maths, and technology. Field altogether, or at least have to compete extremely hard in order to be considered as equally and skilled capable to their male counterparts. And I need not remind any of you of the unfortunate fact that for many, many decades, regardless of their race, creed, or culture, women in South Africa were collectively disadvantaged by a system designed to benefit a very small and elite group of men. As a result, those of us in government today in post-apartheid South Africa now have to work even harder to bridge not only the economic divides, but the invisible divides of prejudice, stereotype, and preconception that have a way of creeping into our personal, business, and learning spaces as women. Because of this, the City of Cape Town made its commitment to the principles of equity and discrimination, anti-discrimination, and diversity very, very clear. Not only do we have a female Premier, Helen Zille, in the Western Cape, but we also have a female Executive Mayor, Patricia de Lille, who through their individual strength and resilience provide an example of for women throughout South Africa, that notions of gender and the limitations that we attach to gender are but psychological constructs. I must also just say that on one note, that the City of Cape Town is very proud to boast a female Doctor of Engineering, Dr. Gisela Keisler, as the head of our Utilities Directorate, which is the largest directorate in the City of Cape Town, who employs over 27,000 employees. I'm sure she would have loved to be here today as well. But in acknowledging back and behave as passive spectators in our lives and the development of an equitable society, one within which women can live and thrive, because there is still so much work that needs to be done. And so today I really wanted to be able to share some of the interventions that we in government are putting in place to ensure that women have at their disposal the very tools themselves. As part of our commitment to building a caring society, we recognize that there is not a one-size-fits-all solution to addressing the structural disadvantages that we are confronted with. The city has worked hard to provide opportunities for young women from our targeted apprenticeship and bursary programs that seek to develop females in areas of scarce skills such as engineering, architecture, city planning. We continue to make great strides. The City of Cape Town is also taking steps to ensure that women and men we serve in our diverse communities have at their disposal the hard tools needed to empower themselves as individuals. Recently, for this particular financial year, the city is spending over 100 million rand towards our skills development program, which ensures that we'll empower young generations to capacitate the City of Cape Town. But in order to drive this overall strategy of educating young Cape Townians, we have defined 5 pillars of governance to ensure Cape Town is focused on achieving an opportunity city, a well-run city, a caring city, an inclusive city, and a safe city. One of the elements of our well-run city divide in our vast city. so that those who wish to pursue technologically related endeavors can do so without any hindrance. In this regard, as I'm sure many of you already know, Cape Town is once again leading the digital inclusion on the African continent via a fiber optic broadband rollout plan. And because broadband connectivity and digital inclusion are fundamental to creating an enabling environment for business development, economic growth, and social cohesion, our new public Wi-Fi provision is a prime example of how the private sector, government, and the public can make progress possible together. So whilst the City of Cape Town has a total of already 350 kilometers of fiber optic cable installed in this fiber, in addition, has 28 buildings are connected via the city's broadband fiber, 25 city clinics connected to either fiber or wireless, and 12 world-class switching centers have now been constructed and are operational. The City of Cape Town has also saved over 25 million rand per annum in our internal internet communication charges. 189 Wi-Fi hotspots and at 102 libraries so that women everywhere can easily connect to the world of innovative ideas, opportunities through the internet services that we provide. And because government cannot transform communities alone, the city has also partnered with 2 commercial service providers in order to provide free data to the poorest of the poor in our wireless zones. Now, the hairdresser in Yanga who wants to advertise her services on Gumtree can do so with ease. And the copywriter in Khayelitsha can email or offer work without having to spend money at an internet cafe. And the young candidates of the STEM program can participate in a world-renowned program through the assistance of MIDO. All of this has become possible through our digital inclusion projects. And in addition to this, as maximize development opportunities for women, this pipeline to ensure that we address our current and future skills need. As I've already mentioned, our training budget every year is over a million rand, and we are that. But in conclusion, as a representative of the City of Cape Town's political administration, I would like to, in a variety of ways, committed to ensuring that all of our residents, from the informal trader in Gugulethu to the engineer at the harbour over there, have at their disposal the very basic tools that most of us take for granted in order to empower them to climb the ladder of success and achievement. We are also committed to ensuring that where women like those amongst us today have an aptitude, that talent does not go to waste, but is fostered to ensure the development and betterment of future generations to come. I would also like to say, because we are in government, understand the importance of having a feminine energy in this world. We are excited and committed to ensuring that we support MIDO in the expansion of this project. And to the participants, I wish you all the very best of luck. I look forward to seeing you grow from strength to strength and becoming leaders of thought, technology, and innovation to ensure that you can transform the African continent and the worldwide globe. Thank you very much.
Xanthia, thank you very, very much. And certainly the support that we've had from City of Cape Town has been fundamental to us being in contact with all the right schools, all the teachers, the maths and science teachers, so that we could engage with the young women and set up the workshops. So thank you very much. We've had a huge level of cooperation from the city. And also it's been a very good demonstration of how we can bring together the private sector and the public sector to really work together for good. So thank you very, very much. And thank you so much for that internet connection. When we were out on our boot camp in the wilderness this last week, our internet was coming and going, and we realized, all of us, how addicted we are in the city of Cape Town now that we have our broadband rollout. What I'd like to do is I'd like to introduce our next speaker, Dr. Ben Malfraz. Ben is a professor from Moorhead State University, who we met in April this year. We went to a small satellite he is doing in the small format satellites. We made absolutely sure that we got ourselves onto a number of aeroplanes, and we were able to visit the team at Moorhead. Absolutely fantastic. And as soon as we walked into the room and Dr. Ben heard what we were doing, he ran out of the room and called Jennifer and said, "You better come and hear what these people are trying to do in South Africa going on." That's been the start of a fabulous relationship. Thank you very much. And he's very modest. It was only since he's arrived in South Africa and with a lot of information from Jennifer that we found out that he discovered a galaxy. He discovered a galaxy which was able to prove the mechanism of the formation of many of the a marvelous, marvelous, marvelous brain in the room, and a man who's going to share how he's taken all his learning and knowledge over many years to be able to contribute back and make the lives of young people a lot more interesting, fascinating, and inspiring. Ben, please, can I hand over to you? Thank you.
Well, thank you, Judy, for the kind introduction, and thank you, Biarca, for the opportunity to be here. It's a pleasure to be in maybe the most beautiful city on the planet Earth. And one of the most beautiful countries on the planet. It's been a true pleasure, so I really appreciate the opportunity. I appreciate the opportunity to be here and to share a little bit about the future. So that's my goal in the next few minutes, is to tell you a little bit about what we're doing and how we came to be here. I'd like to provide a little bit of context in terms of the aerospace economy, because really that is the primary element of the space program at Moorhead State. Certainly we're involved in research and looking for new galaxies and that sort of thing, but we provide economic services and are in the process of developing technologies that are commercializable in support of the aerospace economy. So to provide a little bit of geographic context, where in the world is Moorhead State? North American continent, sort of in the middle-ish of the United States. It's actually very remote. Judy alluded to the fact that she had to take. So we appreciate the effort to come off the beaten path, to come and meet with us. Also, to provide a little bit of economic context, aerospace is an enormous part of the U.S. economy. It's still one of the world's major economies, and aerospace and defense aerospace technologies account for about 15% of the U.S. GDP. So 15% of the world's. Kentucky, which you might not be familiar with, we're sort of known for thoroughbred horses and coal and bourbon, which you might be familiar with. Kentucky Fried Chicken, you might also know. But we're now an aerospace state. So as of 2013, we became an aerospace state in terms of the primary economic driver. And it had a lot to do with the automotive industry. So if you'll bear with me, I'll $1 billion industry in the state of Kentucky. And that allows us now to enjoy a rank of third in the U.S. behind Washington State, who has Boeing, California, who has everything, and now Kentucky is number 3 in the U.S. in terms of aerospace exports. Part of it is owing to micro nanotechnologies and advances in microelectronics and by the automotive industry. If you look at automobiles today, GM, Isuzu, there's something like maybe 25, 30 MEMS devices in a single vehicle. Tremendous number of microelectronics. There are half a dozen, maybe 10 or 12 microcontrollers and microprocessors. So the same technology that's revolutionized the telecommunications industry with your cell phones has revolutionized the automobile industry, and it's also bled out into other industries and helped support the aerospace industry. So we owe a lot to the automotive industry. What we do is focus on nanosat technologies, small satellites that are the size of a loaf of bread, essentially. Judy showed you a picture of one earlier that was a CubeSat, 10 by 10 by 10 centimeter cube. We make those, and we make ones that are a bit bigger, and they have a variety of very practical applications. And I want to walk you through some of those applications so you understand the context. But there are a large number of these small sats being flown now, something like 100 a year or so. There's one company called Planet Labs that has a constellation of 100 small satellites up. The idea is to have a distributed architecture. You can build one big satellite and spend $300 million on it, or you can build 100 small satellites and have greater distribution. So there are applications that constellations of small satellites are actually better for solving certain problems. So that's kind of what we focus on is context. There was a small company that was developed by colleagues of ours called Skybox that was recently bought by Google. 4 or 5 young men who are now billionaires, I'm sure. Yeah, at the ripe old age of mid-20s. So it must be nice. Since I've been here a few weeks, I've noticed some parallels between the economies of South Africa, actually, and the economies of Kentucky. Prior to the 1980s, we were primarily an agriculture state. We grew a lot of tobacco, we had cattle, we still have that to some extent, but we also relied on the extractive industries, primarily coal and natural gases now to a certain extent, but primarily coal. So I drew a parallel there between the extractive industries in South Africa, industries here, gold, diamond, platinum, fruits, and wines are a huge part of the economy. From there in Kentucky, in the 1980s, GM and Toyota came in, and we moved from basically an agriculture and coal economy into a sort of light industry economy, and it was primarily because of the automotive industry. So all of these other small companies sprang up to provide parts for the automotive industry, to provide advanced manufacturing, to provide some, a workforce, a much more technological economy. So now we're an aerospace economy, but it wasn't always that way. So I think it's been very interesting to see the progression. So again, agricultural and extractive industries in the 80s, automotive in the 90s, and now aerospace in the 2010s. So I wonder, seeing some of the parallels in South Africa, what will be next for South Africa? Great hopes for you guys. So just a bit of a snapshot of where aerospace fits in as an economic driver in the state. It's again about close to an $8 billion industry in the state. Automotive is about $6 billion. Industrial machinery, $2.3 billion. I also added distilling in there, which is, we're famous for Kentucky bourbon. It's about a $3 billion industry. And thoroughbreds, well, the racehorses, Kentucky Derby, right? It's also about a $3 billion industry. I didn't include it as a manufactured export, but it's at least an economic driver there. So to put it in perspective. In a little bit more detail about the aerospace industry in Kentucky, it's growing at about a 40% rate per year. So it's really become a big economic driver very quickly. A couple of details, the direct-to-home television dishes that you television, something like 40% of those in the world are actually made in Kentucky now. So it's an important part of the industry for us. We also make the compressor blades for turbine engines for GE that goes into Airbus aircraft. So that's a huge economic. Certain GE engines, all of the turbine blades are made in Kentucky. So advanced manufacturing has led to that. So the job market, as a result, for young people, has become extremely robust. And as a result, we've been able to become one of the leaders in nanosatellite technologies, which we think is sort of the wave of the future. Moving toward the space segment a little bit, now that we've provided a little bit of background about the aerospace economy, to fly about 5 small satellites. I'll tell you about 1 or 2 of them, my favorite ones, since we're limited for time. But we're now also the home of the inventor of the CubeSat, the worldwide standard, which there's a picture of Bob Twiggs there. You can see he invented the CubeSat at Stanford and now at Morehead State University. And we have developed a pipeline, at least the beginnings of a workflow pipeline from pre-college through university to the workforce. So just to provide sort of a organizational context, we are a university, Morehead State University, but we partner very closely with industry. A number of reasons. We're tightly coupled with industry because we want to produce graduates that have the specific skills that are needed in industry. So we change the curriculum. It's very dynamic. We change it all the time, try to make new content. But here you can see that we're part of an umbrella organization called Kentucky Space, which has a for-profit arm and a not-for-profit arm. So, and also a business incubator called the Innovation Launchpad. So it's really part of a fabric, essentially, of universities, private sector, some government support to support the aerospace industry in the state. So moving on to the nanosatellites, which is really our focus. We think the next big thing is small. Again, these satellites are really tiny, the size of a loaf of bread. And again, it's owing to this revolution in microelectronics. I mean, if you look at the technology in your cell phone, it's just incredible. I teach university students, and when I tell them, they don't believe this, but I told them that when I had my first cell phone, when I bought my first cell phone, it could do only one thing: make a phone call. And look what they can do now. The students don't believe it. And then before that, it was attached to the wall, right? They really don't believe that. There are a lot of practical applications for constellations of small satellites, from homeland defense to long-distance telephony, financial transactions, data transfer, internet delivery, Earth remote sensing with excellent refresh rates. There's a company, a small sat company called Planet Labs that can have a satellite overhead any point in the world in about 15 minutes. If you look at Google Earth, the images of Google Earth, those images might be 12, 16, 18 months old. And those are great. They're high resolution. But what if you want to track a forest fire, or if you want to look at flood damage, or if you want to figure out where to send first responders? You need very timely Earth remote sensed information. And that's what these little satellites can do. So they have an extremely practical purpose. So again, we've had the great pleasure to fly 5 of them for a variety of different customers, a variety of different applications. But I'm going to pick 2 and tell you about. But before I do that, I want to tell you, answer the question. People often ask me, how does a small university that's sort of geographically isolated become, a relatively well-known space power? And how do you get to fly satellites? Well, we do it in partnership. We do it in partnership with the aerospace industry, the private sector, and with government. So you can see a list of our partners here. MEDO, of course, but we work with Honeywell. FedEx Space Solutions now FedEx has a space desk. So a variety of different partners we pull together, and then you can have greater capabilities when you work in partnership. So that's our strategy. this sort of shows the geographic distribution of partners. They're effectively worldwide, from Russia to Europe to the United States, and the slide got a little skewed there, but fairly well worldwide distribution. So also, you need a bit of a infrastructure to build the satellite system. So we're very fortunate to have built significant infrastructure at Morehead State that allows us to build these satellites up. But I want to tell you about two of them. The Cosmic X-ray Background Nanosat, CXBN. It's a big word for a little satellite. Again, about the size of a loaf of bread. And this one was one of my favorites because while we build them for a lot of practical applications, this one is an astrophysics satellite. So it's looking at an aspect of the physics of the early universe called the cosmic X-ray background. And it turns out that you can do it better with smaller satellites than you can with big satellites for a variety of different reasons. So we're actually able to build something the size of a loaf of bread for about $1 million that can make a better measurement and lend insight into the physics of the early universe than you can with a $100 million satellite. And I wanted to show you what these little guys look like on the inside. This is mechanical engineers refer to this as an exploded view, but I really don't like to use the word explosion when we're dealing with satellites and rockets. But these are the components of a satellite, and the interesting thing about what the girls have done this week is when they produced the CricketSat, they have actually learned and actually built components, all the components of a satellite. So whether it's a CricketSat or $1 million CXBN satellite or a $100 million satellite, they all have essentially the same components. And these young women have learned about the technology, all of the subsystems. So they could literally go and build a satellite in a few years. Going to skip ahead because I'm running a little short on time here, but I want to tell you about our newest mission, which is called Lunar Ice Cube. We're building a bit bigger satellite. It's a 6U CubeSat, about the size of a big cereal box. And it, fortunately, has been selected by NASA to take a ride to the moon on the Space Launch System. You can see the rocket there. It would be the largest rocket built in the history of the world. It's being built right now. It looks very much like the Saturn V. It has two solid rocket boosters. It will ultimately take astronauts back to the space station and back to the moon. We plan on going back to the moon and ultimately to asteroids and maybe even on to Mars beyond that. So we're real excited. The first time it flies in 2018, EM-1 Exploration Mission 1, it's not going to have astronauts. It will have the Apollo or the Orion capsule. No astronauts are going to swing it around the moon and check it, make sure it all works. Then the next time it flies, it'll have astronauts on it. But the first time they're going to carry along 11 small satellites and drop them off at various is one of the satellites that's been selected. So this little guy is going to get a ride in the direction of the moon and take a circuitous route with a RF ion engine and orbit the moon and try to map the distribution of water ice. Because when we go back to the moon, we don't want to just plant flags and footprints. We want to stay. We want to build outposts. We want to mine the moon for helium-3. There are a number of minerals on the moon we would like to that are actually ultimately will be cost-effective to mine there and bring back to Earth. And so you have to make use of the land, the resources on the land. So water is a very important aspect. So that's what the purpose of the small sat is to map the distribution of water on the moon. So I'm really excited about that. One other quick element of the space program at Morehead State University that the young women have also learned about is called mission operations. Well, you know, you can build a satellite and put it up there, but if you can't talk with it, it's basically a brick in space. So you have to have ground stations, and these young women have actually worked with ground stations and learned how the telecommunications, electronics, and processes work. And so we have a bit bigger system at Morehead State, a 21-meter antenna that we train students in telecommand. They command the satellites as they go over and pull down data and telemetry. We're happy that we're becoming part of NASA's Deep Space Network. There are only 3 nodes on the DSN right now, one in California, one in Spain, and one in Australia. And Morehead State's been selected to be the 4th node. So we're really excited about that. So, you know, we have the great opportunity to provide excellent training for students. We work very closely with industry. It's provided a lot of really good positive PR for us through these partnerships. And I think we have some implications that we need to think about. Where do we go next? We've gotten pretty good at nanosat development, but we really need to strengthen the pipeline just as you guys do. We don't produce enough scientists and engineers and enough female scientists and engineers, so we have largely the same problems. And that's why we're attracted to work with MEDO, is because we so our goal is to develop a strategic initiative to help evolve the aerospace industry in Kentucky. New models for public-private partnerships, spin off new companies from the university, attract new businesses, small businesses to the region, and to evolve the STEM pipeline. And when we met Judy and Bjarka, we thought, that sounds a whole lot like the goals of MEDO. So I think we have extremely consistent goals, so it makes sense to work together. So here's what I envision our partnership with MEDO is. You know, we've launched SPACEtrek, Space Prep and SPACEtrek. You'll hear all about it, wonderful things. But the future is very bright. We love Judy's idea and Bjark's idea of expanding SPACEtrek to the entire African continent. To support the pipeline development and to launch the first private South African satellites, even constellations ultimately of nanosats, to provide a variety of different applications, a variety of different purposes. So I like to think that the sky's no longer the limit for what you guys are doing here. And at that, I will turn it back over to Judy.
Dr. Ben, thank you very much for that, that inspiring presentation. And we were very lucky we were your radio antenna, your receiver, when we were there at Moorhead. It was great. I'd like to hand over to Jennifer now, who's going to take us through, as the founder of Space Prep and SPACEtrek. Jennifer.
Thank you, Judy. I want to paint a picture of the history and evolution of SPACEtrek a little bit. 5 years ago, a seed was planted. There was an idea come up by two women of the American Association of University Women who were meeting at a national conference, and they were discussing some of the findings. And their findings were that 80% of the jobs in the United States were STEM jobs. And in the industry, only 14% of those jobs were held by women. And so that became a problem in their minds, and they really clearly identified a gender gap in the industry. And so what they wanted to do is seek to find a solution to bridge that gender gap. And so along with the partnership of the Space Science Center at Moorhead State University, SPACEtrek, a one-week residential intense camp, was born with a singular goal of empowering young women through STEM education with an aerospace platform. As of last Monday, 59 young American girls have been empowered by SPACEtrek. But thanks to an amazing international collaboration with a very innovative economic development organization, MEDO, we've been able to establish this collaboration and bring 14 young women from South Africa to become empowered by SPACEtrek 2. But guys, make no mistake, that's not easy, okay? So the girls were given a real mission. Their mission was to measure the temperature of the atmosphere up to 5 kilometers. But the key point is their feet had to stay grounded, right? So that's a challenge. And this week, the girls have kept several mottos in mind as they face this challenge. Number one, everything is hard until it's easy. And number two, we do these things because they're hard. And if we have a dream, dreams don't work unless you work. You can hear them. They're repeating it. They know these by heart. Also, girls, why do we do these things that are hard and frustrating? Why do we do it? Because we're worth it. Absolutely. Also, the final motto that we kept in mind is that success only happens when preparation meets opportunities. And so now I'm going to turn the floor over as the first ever graduating SPACEtrek South Africa class, the elements of their mission and their exciting results.
Thank you very much. Hi, everyone. Thank you very much. We were given a mission to measure the temperature of the atmosphere up to 5 kilometers. So we built, calibrated, and launched our own electronic device that wirelessly communicates temperature information. So, okay. As you can see from the diagram, this is the structure of the atmosphere, and the atmosphere is up to 140 kilometers long. And we are focusing below there at the troposphere because that is where the launch would take place and measure the temperature. As you can see, the yellow star there is about 5 kilometers long, and that's where we measure the temperature. And the range of the temperature is between 20 to 25, negative 20 to 25 degrees Celsius. So that's where our electronic device will fly and take temperature readings. Next slide. So here, this is at our camp, we were taught how to use Microsoft Excel to graph data. So, previous slide, please. So, we learned how to label axes and title them, and most importantly, we were taught how to use the data that we were given and to make a prediction out of them. So this here is my prediction. As you can see, as you go up to the atmosphere, the air becomes denser. So as the altitude increases, the temperature decreases because of the dense air as you go up. So here at the graph, here at the vertical line, you are given the altitude in kilometers, and on the horizontal line, you are given the temperatures in degrees Celsius. So now, the altitude here is 10 kilometers, and the temperature is negative 45. And here, the altitude is about 8 kilometers, and the temperature is about negative 47 degrees Celsius. And so you can see that as the altitude increases, the temperature decreases, and so forth. And here, this is where the moment. This is the moment that's very exciting. And here, this is our electron to the helium balloon, and right over there is the ground station. But how? Helena will give you all the details. Thank you very much.
Thanks, Sam. My name is Brittany. I attend Pelican Park High School and I'm 16 years old. I'll be telling you more about the electronic device that we use to measure temperature. The electronic device's name is the cricket set. So why cricket? Crickets chirp at a rate when they, like the temperature, when it's hotter, they chirp more, and when it's colder, they chirp less. So we decided, okay, we need to measure the temperature. I need to tell you more about this device. The most important parts are two resistors. One is a thermistor and one is a regular resistor. Then there's a capacitor, an IC55 timer, and a radio. So what the parts do, resistors resist current. They don't let the current flow through the circuit. The thermistor is a sort of resistor that is temperature dependent. So think of honey. When honey is warm, it flows easier. So the current will flow easier through the resistor. And when it's cold, honey doesn't flow that easily. So the thermistor will have more resistance. The IC55 timer, it takes the current and it pushes it out at a rate, which the radio will switch on and then switch off, and the capacitor is like a device, like, you know when you charge your phone, like the battery, it holds current and then it releases it at a pace. So how do they actually work together? I'll have my teammates, Sam, Noabisa, and Sipelele, to help explain this. The circuit consists of a capacitor and the radio. Let's see how they work in a room temperature.
Okay, I'm the capacitor. My job is to hold current, and when I hold current, I charge. And when I release it, I discharge.
When the capacitor charges, the output is high, and when it discharges, the output is low. So it's high and low. And I'm the radio. When the output of the IC55 timer is high, I light up. And when its output is low, I switch off.
Right? Let's see how fast they go when it's off. Thank you guys. Helped us learn how to build a cricket set. We started with a breadboard. So this breadboard, we used most of the components, actually all the components except the radio, in this breadboard to create the circuit. The LED will be your indicator to show how the IC55 timer regulates the current at the different temperature. Do you see the light flashing? Make it a little bit colder, and the light flashes slower. Thank you. And the next part of our mission was, so the radio goes at a frequency. How are we actually going to get this frequency and correlate it to the temperature? Noah Bisa will...
Hello everyone, my name is Nabisa Sitole and I'm 17 years old. The purpose of calibration, any scientific instrument, is to ensure the measurement it has to be accurate. So we had to use the temperature lobe and the spectrum lab software to establish the standard reference temperature and its corresponding frequency. Then this is our temperature lobe that we used, and then in the spectrum lab and here. And this is our multimeter. So, as Brittany showed you how we use this,
There's a glass of water behind you, and it had
temperature is warm, the light will chip fast, and when it's slow, like cold, it will chip slower. Yeah. We had to use them. After the experiment, we determined the mathematical relationship between the temperature and the frequency. We use the equation to determine the corresponding altitude with the certain temperature. As you can see, the equation that we made, we use it to be able to determine the altitude and the temperature at its temperature when it's up in the sky. Spelele will tell you more about the details.
Hi everyone, my name is Pelele Mzungwana from Manyano High School. So here we have our ground station. So a ground station is basically where we cricket set. So this looks exactly like the ground station that we had at the camp, in how all the components work together. So here we have the IP directional antenna, and how it works is it actually has 7 elements, and of those 7 elements, they work together, showing that they reflect all the signal here to the special element, which is known as the driven element. Yeah, and then also our antenna is connected to an SDR, which is a signal of a software-defined radio, which is over here. So I'm going to connect an experiment. So this is our software. Okay. So as you can see, that's the signal of our cricket set. I'm gonna open the sound. Yeah. Okay. As you can see, that is the signal of our cricket set. Oh. Sorry. Here you can see that this is the signal of our cricket set. This is what happens when I'm gonna spray it for you. You can hear the signal. When Brittany is doing that, she is increasing the temperature, and when the temperature is increasing, the sound goes higher. And I'm going to spray it, and then you'll be able to see what happens when the temperature is cool. The sound goes down significantly. And also the temperature increases. When the temperature increases, the frequency decreases. And that's how we conducted our experiment. We are about to see a video of the launch day, so please enjoy. Okay.
what happened was that the young women divided themselves into 4 groups. So they had 4 different missions, launching their cricket sats with their high altitude balloons, and each group come and give you feedback on their different missions. And because with each one, we discovered something new. So I would like to start with Aisha and Bunny. Please come up.
Good afternoon, everybody. My name is Afternoon, everybody. My name is Paneka Zitandwa, and I'm 17 years old. I attended Nelson Mandela High, and this is my group mate.
Hi, I'm Aisha Sally. I'm 17 years old, and I currently attend Pelican Park High School, and I will be in matric this year. Now, as you can see, this is the data that we collected on the day of our launch. So basically, after 48.5 minutes, we got our data, and then we put it in the computer to plot this graph. Now, as you can see, the frequency decreases rapidly. We think this is because when the balloon was launched, it flew up quickly. And then we see that there's a fluctuation in frequency. But my partner, Bunny, will explain that later in the slides. And then we see again that the frequency decreases steadily. We believe that this is because as the balloon rised up, it started to slow down. And it moved at the rate of 0.607 hertz per second.
So from the frequency graph, we were able to determine the temperature and frequency graph. On this graph, we show the temperature and the frequency at the same time, the change in temperature and frequency. So we started the launch at 2740 Hertz, and the temperature was 48 degrees on the ground. So into the atmosphere, the frequency also decreased at the same time, and to a certain point that it lost signal, because we believe that our balloon went far because that day was very windy. So we lost signal at some point, and we lost signal at 25.9 Hertz and at a degree of -19. And on this graph, we compared temperature and time. We started the launch at a high degree, at the 50-degree level, I can say. As the balloon went up, the temperature decreased as time goes. And you can see the graph has some certain bumps on it. We believe that the balloon hit some hot pocket of air in the atmosphere. So as it went up, it decreased rapidly. A point where we lost signal, as I told you earlier. And we lost that signal at 48 minutes, 0.5, at a temperature degree of -19.
Okay. So after we plotted our data on the graph, we were then given actual data from professionals to legitimize our cricket set to that. So as you can see, this is the data that we got from aviationweather.ca. And from that, so from frequency, we got temperature. So we decided, how about we take it a bit further, and we can calculate the altitude using the equation of V light and place our own temperature into that graph to get our own altitude. As you can see, this is the data we collected from our own cricket set. And you can see the temperature decreases as the altitude increases. And as you can see, the equation is the same. Previous slide, please. Which means that our
And on this last graph, we calculated our altitude and temperature because we launched.
Sorry, you want the previous one? Yeah, the previous one. And we can explain the below altitude. The previous one.
The previous one.
And as you can see, now you might be wondering why our altitude started as negative. This is because the data collected from the aviation national.weather.sa, their altitude was higher above sea level than ours was. So now because we can't basically launch our balloon underground now, can we? So that's why we must say that's a negative, because Worcester was higher up in sea level than what their daughter was.
Okay, on this graph. So on this graph, we determining altitude and time. As my partner said, we can't launch below sea level, can we? But if you start from the point 0, you can see as the graph increase, as the altitude increase, because the altitude is a function of the temperature. So on this graph, the altitude increased, and it also has some certain humps. Like I told you, we believe that in the atmosphere, the balloon hit some hot pockets of air. So because when the temperature decreased, the altitude increased. So at this point, when the temperature was increasing, the altitude decreased a little. So after that, the temperature just increased rapidly to a certain rate of 2 meters per second.
Okay, wait, and one more thing. Okay, now if you take this, right, that means that our altitude is basically 3 meters higher than that. So basically, if you add 3 to that, our balloon, a helium-filled balloon, basically went up to 10 kilometers high. That is 2 kilometers below the troposphere, the lowest point of the atmosphere. Thank you.
Good afternoon, everyone. My name is Erin. I'm 17 years old and I attend Zandvliet High School. I'll be doing the graph. Oh, there we were like launching the balloon and I had to let go because we were like about to fly the balloon off. Yeah. I will be doing the temperature over the time graph. We had to redo our balloon, our launch, because there was some signal interfering in the morning. So I had to redo our one, and then our temperatures were like lower than the other group's temperature. Our maximum temperature was 24 degrees Celsius, and our minimum temperature is 21.54 degrees Celsius. The balloon went up from the surface at 24 degrees Celsius, and while it was decreasing, we lost signal. That's why the gap is here. The temperature continued decreasing, and suddenly, it continued decreasing until 10.5 minutes, which is 10 minutes in 30 seconds. The temperature increased again because of a possible air pocket, which could have been a possible air pocket. It then decreased again until it reached another air pocket there, and we lost a bit of signal as well. After that, the balloon was decreasing, the temperature was decreasing again until the balloon popped at 78 minutes and minus 21.5361 degrees Celsius. Afterwards, the balloon popped and the temperature increased again until we eventually lost signal of the cricket set that was approaching the surface of the Earth. Thank you. And now hand over to Tanya.
Hello everybody, my name is SPACEtrek. I'll be presenting this graph as it's calculated change of altitude over time. We started recording data on our altitude at just over 200 meters above the Earth's surface. And our graph is special because we launched at night. So our temperature is a little different, which affected our altitude because, well, there's a change in temperature, there'll be a change in altitude because they're inversely proportional to each other. As you can see over here, we lost signal, as she said, so we did not have any data for for a small amount of time, but we gained our signal, and just after that, we hit this hotspot. It may seem like our balloon is moving up and down, but it's not. It's just that our altitude is a function of our temperature, and our temperature was decreasing and increasing, so we just had to put it in there like that because it couldn't be a straight line. Our balloon is not moving up and down, it's just the hot spots make it look like it's moving up and down. And over here, this is like our hot spot. And then our balloon moves and hits a few hot spots. You can see there's 1, 2, 3, and 4 over there. That's quite a few. So it would have caused a problem in our data if we didn't know it was hotspots. We'd have thought our balloon is going up and down, and that's impossible because our balloon can only go up since it's filled with helium. And our balloon popped at about 78 minutes, and that caused a descent in the. But what is interesting is that the rate at which it fell down is much smaller than the amount of time it took to actually get up there, because it took about 1 hour, 30 minutes to actually get up, and then about 6 minutes to get down, which is really interesting. And then when it went down, it didn't stop at the place where it started. It actually lost signal at about 3,000 meters above the Earth, whilst we started about 2,000 meters getting signal. So we lost our cricket stats, but we gained data. As if we'll elaborate more about our ascents and descents. SCP.
Good afternoon, everyone. My name is Asipe. I'm 16 years old. I'm from Nelson Mandela High School. I'll represent the graph of rate in ascent and descent. And this is the graph of ascent from 0 to 10, 5 minutes. Oh, before I forget, we had to split our graph into 3 graphs because of the ascent. It had 2 different rates. So this is the first ascent, from 0 to 10.5 minutes. As you can see here, my fellow teammate has already said that. This is the hotspot. This is the hotspot. And the equation of this graph is our altitude is, as the function of time, is equal to 0.2702 t plus 0. This graph is not a straight line graph. It's just that it had a hotspot in it. This is our second hotspot, and the equation of this graph is altitude is the function of time is equal to 0.0824 t plus 2.2085. Okay. The descension occurred just after the balloon is popped at 78 meters. After 78 meters, at the temperature of minus 21 degrees Celsius, the temperature started to increase again at the rate of 0.812 for about 6 minutes after the detention has occurred, and then we lost the signal.
Good afternoon, everybody. My name is Amanda, and my surname is Luchetu. I'm 16 years old, and I attended Spamandla High School.
Afternoon, everyone. My name is Leisila Jomo from Manyano High School. I'm 17 years old, and I'll be doing matric in my school this year.
Good afternoon, everybody. My name is Abigail, and I'm 17.
Presentation. Okay. I'm going to be presenting a temperature versus time graph. And here in the graph over here represents a temperature, okay. The starting point here elaborates the temperature at which the graph was released. the balloon was released at about 49 degrees Celsius temperature. As the time goes by, the temperature keeps on decreasing. And if you take a good look here, we have a circle here which elaborates the time and the temperature at which the balloon popped. Our balloon popped at 115 minutes. And because it is then going to come down to the air, our temperature is increasing. If we take another great look in this graph, there are two specific points here, which we refer to as outliers. Outliers can probably be caused by hot or cold air pocket bags, which in this case you can say that they are caused by cold air pocket bags. I'm handing over to my teammate, Lucy.
Hello again, everyone. Our cricket set was launched at 16:01 p.m. exactly, and my graph shows altitude versus. I started at negative 3,000 meters or negative 3 kilometers and then started ascending. The arrow here shows that our graph was ascending, and then the cricket set was ascending because it was flying it was attached to a helium-filled balloon, and then it reached a point here at about 6,500 meters or 6.5 kilometers at a temperature of negative 18.02 degrees Celsius. That's when our balloon popped and then descended to the Earth's surface. Next slide, please. This graph shows altitude versus time. Our graph from the previous slide shows that it ascended at negative 3 kilometers. The reason why it ascended at negative 3 kilometers is because we were below sea level. And then here in this graph we have two outliers. This happens because there were air pockets in the atmosphere. And the other reason is that our graph, our cricket set was in the atmosphere for about 2 hours. So that's why there are outliers there. And then the circle over here shows that that's when our balloon popped at a temperature of negative. It will be on another slide. Okay. It popped at 114.5 minutes and the altitude at 6.5 kilometers. And then here, the graph is not ascending in a straight line because the temperature was windy because it was late and because our cricket set stayed up there for 2 hours long, more than everybody else's. That's why it won't be in a straight line. Yeah. Thank you for listening. I'll hand over to Ed.
Now this graph, thank you. This graph represents how the balloon ascended until the time it popped. The trend line here shows that the speed of the balloon were 59.9 meters per minute. Next slide, please. After it popped, the balloon descended, in the negative direction. And the trend line here shows that the balloon descended at the speed of 0.0126 meters per minute. And the last point there shows that we received no longer signal. And it took the balloon 6.5 minutes to descend the point where we lost the signal. And what made our mission so extremely unique is the fact that it took 2 hours for our balloon to ascend to reach the key point, which is up to 5 kilometers. And thank you for listening.
Good day. School. So the first job
The first chart is a temperature profile. As you can see, the launch started at 21.5 degrees Celsius, and it was cooling down at the rate of 1.68 degrees Celsius per minute. Over here, as it seemed that the temperature was increasing, the balloon passed a hot pocket of air. Then it steadily decreased again at the rate of 0.85 degrees Celsius per minute. Over here, at exactly 51.5 minutes, the balloon popped, and the increase is just the temperature of the cricket set when it made its way back down to the surface of the Earth. Over here is the cricket set altitude versus temperature. It is the inversely proportional relationship between altitude and temperature, which basically means as the altitude at our lowest point at 1 kilometer, the temperature was 21.5 degrees Celsius, and at our highest point of 8 kilometers, the temperature was minus 23.6 degrees Celsius. Over here, we have some data of the aviation data we got from the weather station in South Africa in our cricket set data, both at the temperature of 0 degrees Celsius. So the aviation data was 4.58 kilometers, in our data was 4.36 kilometers. So the difference is 220 meters. So the two dates are within range of each other. The next slide is the altitude profile, which just shows the hot pocket of air in the previous slide, where the altitude it started, where the balloon popped, and the total flight time was 58 minutes. Okay, so now I'm going to give over to my colleagues, Nikki, where will she be going, just explaining more and elaborating more of the different sections of this graph.
Good afternoon, everyone. I am Nikki Wejela from Dr. Nelson Mandela High School, and I'm 17 years old. This year I'll be doing matric. I'll be talking about the rate of ascent for the first 22 minutes of the graph. 5 minutes, the rate was at 0.43 kilometers per minute, and the graph continues to ascend, but changes the rate to the rate of 0.19 kilometers per minute. And suddenly over here, we see a decrease, which is where we experience our hot pocket of air. It means the atmosphere was a little bit warmer than what we expected. But then it ascended again up at the rate of 0.21 kilometers per minute. Next slide. And the rate of ascent from the 22 minutes until the balloon pops. From the 22 minutes until the balloon pops, the rate was at 0.12 kilometers per minute, and our balloon popped at 51.5 minutes. And now we're talking about the rate of descent. The rate of, from this is the point where our balloon pops at 51.5 minutes, and the rate of the descent was 0.89 kilometers per minute. That was the cricket set going from the atmosphere until the surface of the Earth, which means at 58 minutes, that is our total flight. The cricket set took about 6.5 minutes from where the balloon pops and up to the surface of the ground. In conclusion, we as the young girls, we have proven that as altitude increases, the temperature decreases. But that is not always the case. For example, the hot pocket of air. Our balloon went up to 8 kilometers, which is 3 kilometers up than what we expected. And also, I would like to thank the media team for organizing this camp. We have learned a lot and gained more experience. Thank you very much.
So wow, it's really hard to follow an act like that, isn't it? For a counselor, I myself was once in their shoes at this very point in time. My name is Kennedy Hott. I'm a junior at Morehead State University in Kentucky. I'm majoring in space science engineering, and I am one of the 59 campers that Miss Jen told you about earlier. And this is what happens whenever we focus on young girls and we inspire them and we encourage them and you can create products just like me. I come pre-packaged and everything. No, just kidding. So, SPACEtrek gave me a lot of things. It gave me knowledge, it gave me confidence, and it gave me connections. The knowledge that it gave me was the ability to pass my first electronics class, my freshman year of college, with flying colors. The confidence that it gave me was not only from presentations just like this and being able to experience the adrenaline and the rush and talking to you fine people here today, but also confidence because we had perfect examples like Miss Shin of women in our field. Now last, the connections that it gave me just so happened to be when I presented that day, happened to be my lovely academic chair, Ben Malfris, who I met that day, and later now he inspires me to choose my classes every semester, and he's also my perfect connection to the rest of the space science world. Also sitting in that audience happened to be the Dean of Science, which it never hurts to know an important person like that in your community. So, we talked about an important motto at the camp. So what happens when preparation meets opportunity? Success happens. So this was the preparation part of my life. Next slide, please. And this is the success part of my life. Not only did I major in space, I attended my very first rocket launch in Virginia that held a satellite that we built at Morehead State University, completely in-house and by the students. I was able to acquire a work study at the Space Science Center, where I am now in charge of marketing, which I feel is a fitting job for me. I was also able to study under Bob Twiggs my freshman year, who is the inventor of the CubeSat, which is a universal standard used in space, to present at the CubeSat workshop in California in front of some of the finest minds in our space engineering field. And that is also where I was able to meet the fine company of Mido. That I was able to intern at Cal Poly. And after that, I interned at a company called ArduSat, which is also a spin-off company of Spire, which builds a lot of CubeSats. And then I also got to talk to 400 women over the past 2 years at a conference called Young Women Lead, where I continue to do the same thing to women just like this. And now I'm here, and it just feels like the possibilities are limitless, and it all started just with this camp. But what I want you to remember is that the most important part of this is these girls here today. They've worked so hard, and they're so amazing, and they're so perfect, and they're so confident, and they can do anything that they set their mind to. And when I introduced myself the very first day, I listed some of these accomplishments, hoping to inspire them. And Miss Shin asked me, she said, "Kennedy, where do you see yourself in 5 years?" And I had no idea what to say because I felt so overwhelmed because I realized how successful I was at that moment. It was like coming from beginning to end. And my only answer that I could say was to completely rule the world. So in all seriousness, I hope that this camp has given these girls feel like they can completely rule the world. Thank you.
My goodness, can we give another round of applause for all
What an incredible day. So today I wanted to talk to you about how successful you can come from SPACEtrek. SPACEtrek is very mentally, emotionally, and physically exhausting. But also, at the end of the camp, right after you present, you have a feeling of empowerment and confidence, and you feel successful. And not only that, but you feel inspired to continue on this feeling. So just like myself, I went through SPACEtrek, and thank you. Do we have the clicker? All right. So just like myself, I went through SPACEtrek, and I wanted to become more involved in the space community. So I entered a competition with 100 participants, and it was called Mission Discovery. Girls team, because of course. And at this Mission Discovery, we had a mission just like SPACEtrek, where we had to come up with an experiment that will be sent to the International Space Station. So because of the skills that I achieved,
during SPACEtrek, our group was able to win the competition. So these skills that I achieved was taking a mission and coming up with an efficient plan and being able to present to a group of. So I hope that you can take the confidence that you guys had this week and got this week, and you can apply it to everything in your life, and that you this because you guys can, and you guys are awesome. And I hope you are just as empowered as I was empowered, and I hope you had a fantastic week, and we love you guys, and we are so proud of you, and you guys can do anything, because just like Kennedy and I, we have done, and you guys can do the exact same thing. So I hope you can take this and take it into just whatever else that you do, because you can, and we love you guys. So thank you very much. And another round of applause, because they are awesome. Well, these are the sponges that will be launched on the SpaceX resupply mission at the end of the year. These are just a couple examples of the ones that will be going up. Yeah, the International Space Station, yeah.
Emma's also very humble. What it is that with hundreds of entries, she and her team were able to get their experiment where they're going to be growing some sponges in a microgravity environment to do some tests, which are going to be very informative for how we're able to live in an environment with less gravity than we have now. So Emma, you're very, very humble, and I really encourage everybody to speak to Emma afterwards and actually find out exactly what that is going to be. That really a privilege, and something that came out of going on a camp exactly like this one. So what I'd like to do is I'd like to talk about, so where to from here? This is not simply a flash in the pan. This is not something where we are only doing this once off, never to be done again. So what we've done is, with the resources, in other words, with the money that we have secured, we are able to run our space prep workshops, which are our one-day workshops. We're going to be doing 45 of those throughout the rest of this year, impacting in the region of 500 young women. We're going to be able to hold a further 3 boot camps like we've just completed this week, impacting a further 45 people. And also, of course, because we've already bought and paid for it, we're going to be having our satellite launch, which is anticipated for the 3rd quarter of this year. However, what it is that we really need to expand this program to the rest of South Africa. Currently, our resources are covering what we can do in the Western Cape, but we need to be able to expand this program. What we are able to do, because we do have the resources, we simply don't have the money to do it, is we want to be able to run space prep workshops every single weekend throughout the whole country, as well as undergraduate students from the engineering faculties of our universities in the country. We also want to be able to run SPACEtrek boot camps in every province, utilizing undergraduate students. What we've also done is we've been in discussions with Dr. Malphus and his team, and what we want to be able to do is secure satellite launches all the way through to 2020, and to be able to get involved in a lot of the programs that are coming up. And with that, that is really my call to action, is to say, yes, we've started, we've demonstrated we can deliver, and we have 14 ambassadors for the MEDO space program for us to be able to take it across the country. Once again, very many thanks to Craig and his team for their support. They've put in the initial investment for us to start this program, and we're very pleased to be able to demonstrate that we can deliver. So Craig, to you and your team, thank you very much. Miss Jen and, and Dr. Ben, thank you very, very much for coming all this way to help us with the boot camp, as well as to Emma and Kennedy, your alumni, for their tireless efforts in putting it all together. And of course, last but definitely not least, the Meadow team. Thank you to you all. Everybody has really pulled on this one. We've done all the preparations during the holidays, and we've been working weekends, we've been working public holidays, and on this boot camp, we've been working well into the night, sometimes even up to midnight. So the team, thank you very, very, very much. As it is, we do everything as a team because there's no I in team. Thank you all very, very, very much. I'm sure that there are a number of you who have some questions. And so what we're going to do is we're going to avail ourselves for questions and answers with some snacks in the neighboring room. And what we're going to do as well is in about 10 minutes from now, we're going to have a graduation ceremony where we're going to be handing out the certificates, photographs of all our graduates of the program. So please feel welcome in the neighboring room to get some refreshments for yourselves. It's been a long afternoon, and then we can proceed with our graduation ceremony in around 10 minutes. Thank you.